another episode of MrLopezClasses.com. In this episode, we are going to continue in our book of corrosion, marine corrosion, and this is the chapter 4. And we are going to talk about the marine environment and how the environment is critical in the process of corrosion. Depending on the quality of the environment, the process of corrosion is accelerated, and depending on the quality of the marine environment, your boat is corroded or is affected. Yes, the marine environment, the quality of the air is critical, is important. And we are going to analyze how that situation affects the process of corrosion in our boats. And we are going to start checking the air, the quality of the air, the composition of the air. But believe it or not, the air is not only oxygen. Oxygen is not the principal component on the air. Yes, oxygen is around 21%. The rest, the majority, is nitrogen. Nitrogen is around 78%. Is a lot of nitrogen. The majority is nitrogen, and oxygen is only around 20%. And the amount of oxygen decrease with the altitude. This is at sea level. At higher altitudes, we have a less amount of air. Around 20% of air, 78% of nitrogen, and other components, other gases, and vapor, water vapor. This is the composition. The other components are sulfur dioxide. That's not good, but it's not too much. It's only one part per million. Methane, nitrous oxide, ozone, nitrogen dioxide, carbon monoxide, and ammonia. But in little amounts. Depending on the pollution, those amounts increase. Depending on the pollution, for example, this one is not good. Carbon monoxide is not good. This is a bad ingredient. But the carbon monoxide increase. Now we are going to analyze with the amount of cars, gas, and diesel, because the majority of the carbon monoxide is coming from the incomplete combustion of internal combustion engines, gas or diesel. Right now we are going to check what happened and why the carbon monoxide destroyed the environment. What is, for what reason? What is the phenomenon? Those are the other components. Unpolluted air. The atmosphere is a mixture of different gases, but the demand create additional gases, additional pollutants that destroyed the environment. And those gases goes into the atmosphere and create a lot of problems because produce bad ozone. Right now we are going to check what is the meaning of that. The atmosphere contains a small amount of carbon dioxide. It's around 0.04% of carbon dioxide. And the exhaust gases produced on the internal combustion engines, they produce a lot of nitrous oxide, sulfur oxide, carbonous oxide, phosphorus oxide, and those elements in combination with the humidity are catastrophic and increase the global warming. Now we are going to check what is the meaning of that. The majority or the most common pollutants. Other pollutant gases which are released into the air when the fuel is burned incomplete produce a lot of carbon monoxide, nitrogen oxide, sulfur oxide. The incomplete combustion of fuels release small particles of solid like carbon, air, and other solid particles that affect the environment. Right now we are going to check what is the meaning of that and how those particles affect. Let me explain something. The majority of those bad components, nitrous oxides, sulfur oxides, carbonic oxides, those are produced for the incomplete combustion of of internal combustion engines, gas or diesel. This is the picture. The nitrous oxide, sulfur oxide, phosphorus oxide, carbonic oxide. Those oxides, combined with humidity, with water, produce acids. Nitric acid, sulfuric acid, phosphoric acid, carbonic acid. Those are acids. Yeah, this is acid rain. And those acids attack everything, destroy everything, not only the metals, destroy the concrete, the buildings, everything. Yeah, not only metals, attack everything. This is the acid rain. It's basically the incomplete combustion of an internal combustion engine, gas and diesel, plus humidity. Produce acid, and those acids attack the environment. That's the problem. That's the inconvenience. And we are going to analyze right now what is for what reason you have those inconvenience. For that reason, in the future, we are going to avoid slowly those inconvenience if we migrate for example, to electrical cars, solar powered equipments, and we avoid use gas and diesel less and less every day. The only fuel that I recommend today is biodiesel. With biodiesel, you reduce those emissions a lot. You remember how much is reduced? You remember? Look, the carbon dioxide is reduced 78%. The carbon monoxide, this is bad, practically 50%. The hydrogen, they are acids, 67%. Solid particles, 47%. Other toxics in between 60 and 90%. Sulfates, sulfur oxide and salts, sulfurs are reduced 99%, practically total. This equation is good. This is biodiesel. This is biodiesel. And I explained in our course of diesel how to produce biodiesel. You remember? Okay. With biodiesel, you reduce the amount of pollutants, practically 80% in total. This is a lot. This is good for the environment. The other fuels coming from petroleum, they are not good. They produce a lot of nitrous, sulfur, phosphorus, carbonic oxides. This is not good. This is lethal for the environment. Those pollutants destroy the environment. We need to migrate in the future every day more to the electric transportation, to the hybrid and the fully electric cars. For that reason, you, the future engineers, you need to investigate, you need to create new boats, new cars, new airplanes with other technologies, not depending of the fuel regular oil components, depending of the solar, the wind, the water. Yeah, that's the future is in your hands. Because I am finishing this. I think that this is my last project, but you are at the beginning of the equation. You have a lot of time to create. All right, my friends. I hope you change the world. Yes, look at this. Biodiesel, the regular cetane, you remember, we mentioned in our course of diesel, cetane is in between 42 to 44. This is the regular cetane for petroleum diesel. But with biodiesel, increase around 70. It's a high cetane. What is the meaning of that? The meaning of that is with higher cetane, the combustion is complete, and there are less subproducts at the end. And yes, more complete combustion, and at the end you have less sulfurs, less nitrous, less carbons. This is because the cetane number is higher. This is one of the reasons, but I explained better that situation in our course of diesel. Okay, my friend. Now we are going to talk about the pressure of the air. What happened with the pressure of the air? The pressure of the air at the sea level is around 14.7 pounds per square inch. What is the meaning of that? 14.7 pounds per square inch. This is psi. 14.7 psi at sea level. Nice. And what happened when the altitude increase? Oh, the pressure decrease. Exactly the same like with the concentration of oxygen. You have higher concentration of oxygen, around 21% at the sea level. But at higher altitudes, the amount of oxygen is less. For that reason, and higher altitudes, you need oxygen, or your car need a turbocharger to compensate that difference. Yes, that's the reason. The pressure is exactly the same. You have higher pressure at sea level, 14.7, and you have the pressure decrease. For example, at 10,000 feet is around 3 kilometers. The pressure is 10 psi in comparison with 14.7 at sea level. Yeah, this is important because depending on the altitude, you have less oxygen and you have more pollutants. Yeah, that's not good. At sea level, the situation is better. At sea level, you don't need a turbo at sea level. Yeah, you don't need extra oxygen at sea level. For that reason, if you have problem with your lungs, the doctor recommend try to live in an area at sea level. The pressure is better, and the amount of oxygen is higher, and is good for your health. That's the reason. For that reason, the doctor recommend change your home for other home at sea level. It's better for you. And change your neighbor. You are in Manhattan, in New York. Too much pollution, too much buildings, too much smog. Oh, go to other area with more trees, more oxygen. Yes, more trees, more green, more oxygen. All right. Now we are going to check the layers of the atmosphere. And depending on the layer, you have more oxygen, less oxygen, more pollutants, less pollutants, more pollution, less pollution. Okay, the atmosphere is divided in 5 main layers. We have the exosphere, thermosphere, mesosphere, stratosphere, and troposphere. The closest to the surface of the Earth is the troposphere. And the last one is the exosphere. The troposphere is close to the Earth, is close to the surface of the Earth. And now we are going to check what happened in the closest layer, in the troposphere. The troposphere, the thickness is in between 4 and 12 miles, is around 7 to 20 kilometers. It's not too much. That's the thickness. And in that small layer, in the first one, in the troposphere, is concentrated the majority of the atmosphere. Half of the atmosphere is over there. And of course, the temperature of the atmosphere of the air is higher as close to the surface of the earth, and the temperature decrease when the altitude is increment. Okay, and close to the atmosphere, to the surface of the earth, we have the majority of the water vapor, and for that reason, the majority of the clouds are created close to the surface of the earth, where the majority of the vapor is concentrated. Yeah, is in the troposphere. In the troposphere. Okay, my friends, and now we are going to check the second one, the stratosphere. The stratosphere is the second layer. Is around 31 miles, 50 kilometers over the surface of the ground. Yeah, it's 31 miles from the surface of the wire. Start the stratosphere, the second layer, and in that layer, the ozone is abundant and heat the atmosphere and absorb the majority of the radiation from the sun. And right now, I am going to explain what is the meaning of that and how important is that second layer, the stratosphere, and how important, how critical is for the conservation of the life and for the conservation of everything, for the protection of the human the human bodies and the protection of everything. All right, is the second layer, the stratosphere. And right now, I am going to explain what is the meaning of that. In order to understand that, we are going to talk about the ozone. What is the meaning of the ozone? What is the formula for ozone? Is O3. Is O3. You remember that the oxygen, the molecule of oxygen, is two atoms of oxygen, the single oxygen. O2 is two atoms of a single oxygen. You remember how many electrons have oxygen in the last orbit? Oxygen have 6 electrons in the last orbit. Is in the group number 6. Oxygen, sulfur, selenium, tellurium, polonium. Oxygen have 6 electrons in the last orbit. Okay, and both atoms share a couple of electrons, and both of them, at the end of the day, they have 8 electrons in the last orbit, the octet rule, and that molecule is stable. But that relation is not strong. It's not permanent because it's covalent. You remember? It's covalent. It's not strong, it's not permanent. It's covalent. For that reason, separate that molecule. Separate that molecule is easy. And this is the problem with the ozone. Yeah, this is the ozone. There are two types of ozone. The ozone created close to the surface of the Earth is bad ozone. And the ozone in the stratosphere, in the second layer, is a good ozone. And now I am going to explain why, for what reason. What is the meaning of the ozone? Ozone is ready to react, is good for cleaning purposes, for disinfection, but it's not good if you breathe the ozone because damage your lungs. That's catastrophic. And also, the ozone close to the surface of the Earth corrode building materials, monuments, natural rocks, everything. Corrode everything. Is highly corrosive. The ozone close to the surface of the Earth is a detergent and clean and attack everything. That's not good. How is produced the ozone close to the surface of the Earth? By man's hand, by your hands, for you. Yes, with your car, with your motorcycle, with the incomplete combustion of those engines, gas and diesel. Yes, let me explain why. I have an example. You remember that the cars, gas and diesel, they produce different oxides, oxide of carbon, sulfur, phosphorus, yeah. We are going to check one of these. For example, the oxide of carbon. There are two oxides of carbon. Carbon dioxide and carbon monoxide. Why carbon dioxide is not bad? Because that molecule is stable. You remember, you have a one oxygen, other oxygen. Each oxygen have 6 electrons in the last orbit. Okay, 1, 2, 3, 4, 6, the black ones, and the carbon have 4 electrons in the last orbit. 1, 2, 3, and 4. Which one have more energy? Oxygen, because oxygen is located in that corner of the periodic table with more electronegativity. Oxygen need or attract 2 electrons from the carbon. Okay, this electron is going here, the other one is going here, this one is going here, the other one is going here, and this one complete 8, and carbon 0. And that molecule is stable. That's clear? Carbon dioxide is stable. It's no react. It's solid particles. Only produce pollution because it's solid particles. Yeah, carbon. Carbon dioxide is accumulated in the filters. That black area is carbon dioxide. All right, but no attack. Carbon monoxide, the second one, is 1 atom of carbon and 1 atom of oxygen. The oxygen with 6 electrons need 2. Okay. Those 2 electrons goes over there, and those extra 2 electrons are free. They are free. That molecule is not stable. That molecule needs other single atom of oxygen to be stable. That molecule is checking in the environment for an extra oxygen. The oxygen that you breathe is O2. The O2, the molecule is not strong. You remember, it's covalent. When the carbon monoxide passes in front of a molecule of oxygen, separate the atoms and attract 1 atom. That atom of oxygen enter here. That atom of oxygen enter here, and the carbon release those electrons, and right now the molecule is stable. But the other single oxygen right now is free in the environment and is combined with other O2 and produce O3, ozone. And that ozone is bad ozone because it's close to the surface of the Earth. That's the explanation. The incomplete combustion of the internal combustion engines, gas or diesel, produce different oxides, incomplete oxides, and those oxides separate the molecules of oxygen and attract a single atom. The other single atom of oxygen create with other O2 create O3, ozone. But that ozone is here, close to the surface of the Earth. That ozone is highly corrosive. That ozone corrode, attack everything. Simple. What happened with the ozone produced on the stratosphere? This is good ozone. How is produced that ozone? Is the interaction of the ultraviolet sunlight. The sunlight separate the molecules of oxygen on the stratosphere, and that single atom of oxygen with other O2 create O3. But that O3, 50 miles from the surface of the Earth, is excellent because that O3 reflects the X-ray and protect the surface of the Earth. Finito. This is the explanation. The O3 produced on the stratosphere is good. The O3 produced close to the surface of the Earth is not good. The O3 produced close to the surface of the Earth is because you and me. The O3 produced over there is good ozone. It's produced for the interaction in between the sunlight and the molecules of oxygen. Simple. You like it? That's the explanation. Yes, there are 2 types of ozone. bad ozone close to the surface of the Earth, and good ozone on the stratosphere. The good ozone reflects X-rays. If the ozone over there, that layer of ozone is broken, the ultraviolet rays pass and attack the skin, produce cancer, and destroy everything. How it destroyed that layer of ozone over there? When you release fluorine and chlorine into the environment. How? When you use the odorant, fluorine, when you release to the environment the freon, the refrigerant of the air conditioning equipment, that refrigerant is high concentration of fluorine, chlorine, and goes over there and destroy the ozone. What do you think about that? Yes, my friends. We can help. How? Don't use the odorants. Don't use paint in spray. Try to avoid use air conditioning equipment. The freon, those gases, destroyed the good ozone. They are fluorocarbons. You remember that slide? This is the component of the freon, the refrigerant. Fluorocarbons. Fluorine, chlorine, carbon. That's no good. Okay? You like it? Right? This is the explanation about the ozone, the atmosphere, the stratosphere, and yes, those are the hydrochlorofluorocarbons. They are basically on the refrigerants, the aerosols. With those elements, you destroy the environment. Try to avoid that. I think that it's not difficult. We can help. We can help with the construction of a better life. How can we improve the production of a good ozone? Here, with more trees, more plants, more green. Those plants, those greens, during the photosynthesis in the evening, create good oxygen for the environment and good ozone that goes over there. Yes, we need more green, less concrete, and more green. That's the secret. It's not complicated. It's simple. I hope you enjoy this chapter.